Hello. Today we're going to be looking at the geologic geometry. So we're going to be looking at creating the edge of an embankment for a road geometry question, embankment on a cut for a road geometry question when the road is rising. So I've gone over the key principles that pupils will need to have known just for a flat road, and many of the key principles overlap here as to when the road is rising. So for example, the relation between this and horizontal cutting planes is very much the same. The only difference is because the road is rising, we need an extra fill of mass or fill of dirt or clay or however you want to imagine it to support the road rising compared to if the road was just flat. So before we start, we're just going to look at the main points of the question. So point C here is at a height of 30 meters. So for a formation is at a height of 30 meters to the ground. The road's rising from C to B at a height of 1 meter for every 15 meters we travelled. So the side slopes for cutting is 1.5:1 and embankments is 2:1. So we need to put that into the distance between our contours. We need to relate the ratio to that there, because as I explained already, we need to find heights that match up to the heights of our contour lines. So if we're creating these horizontal cutting planes, we need contour lines to match up with them. So I have it created in here, drawn in here already. So if I was to travel down 5 on our cutting slope, then the distance out would be 7.5, because our ratio is 1:1.5. So if I took a horizontal cutting plane at this level here, then the distance from this point out to here would be 7.5 meters. Same thing applies over here. So we've got a distance of 10 meters between, 10 meters if we travel down 5 meters. And then over here, if we were traveling up 5 meters, then we will need to have traveled 75 meters on our road gradient. So I'm not going to be creating the edge of our embankments for this side of the road here, the southerly side, because this car park here is involved, and the two sides of our car park here are going to be level because the road is rising in that direction there. That means this side of the car park and this side of the car park will be level, and I've already gone over those principles, so I think there isn't much point in me explaining them again in this video. So I'm just going to be doing the northerly side of the road here. So to start off, looking at how pupils need to complete these questions, we need to find a point at the side of our road. That's one point, and because our contour lines travel in, or the distance between our contour lines is 5 meters, I can travel down the road 75 meters and find a height there. So I'm going to do that now. So here we go, 75 meters here, and up to here. Okay, so I now know that at this point of the road, my height is going to be 35 meters from sea level here. So what we do now is we need to create our fill cone. So what we have is we need to join our two ratios together. So we need to join the ratio of our fill cone by the height that the road has risen between these 2 points. So if I had went another 75 meters down here, then I would be looking to create a relationship between 10 meters and my cutting slope. So that would be the distance of 15 meters out. But because I only went 5 meters up or 75 meters down the road, I want to join that together. So I'm going to be looking at a fill cone of 75. So I'm going to just create that now. So there we go, 7.5 there. I'm going to draw on my fill cone. So this is the key principle that pupils will need to understand when completing these questions, is how to create a tangent, because we need to create a tangent from this point, or from this circle, back to this point here. So this would have been something pupils would have studied back in junior certs, so it'd be a long time ago, but